Okay, so today we're going to talk about mole-to-mole stoichiometry. Now, so far you've watched the intro to stoichiometry where we used a real life example talking about sandwiches to work these types of problems, and you have done a virtual lab on this stuff. So today we're going to talk about a first type of problem regarding chemistry and using our chemical equations to solve mole-to-mole stoichiometry. First, let's kind of review back on the other day. If I have a balanced equation like for salt, remember if there's no coefficient there, it means there's one of that. So my balanced equation for salt, remember equations have to be balanced according to the law of conservation of mass. Um, these numbers tell me the number of molecules. However, we come up with the term of moles to bridge the gap between molecules and grams, and we're going to think of these terms instead of molecules as individual molecules that we can't count anyway. We're going to say those numbers are in moles. So the ratio of this reaction would be for every 2 moles of sodium that reacts, 1 mole of chlorine would react with it, chlorine gas, and it produces 2 moles of sodium chloride. All right, that's my simplest ratio. That's what the balanced equation is. It is the most reduced down, simplest ratio of moles that it takes, to balance the reaction. But let's say I don't always want that number. I'm always going to, if I'm in the lab and let's say my goal is to make 50 moles of sodium chloride, well, then I would need to know how much sodium I would need and how much chlorine I would need. So if this number, if I wanted to make 50 moles of sodium chloride, how would these numbers change? Well, the chlorine is a 1 to 2 ratio, so if I have 50 NaCl, that's going to be 25 right there, chlorine. And then for sodium, it's a 2 to 2 ratio, which is a 1 to 1. It would need to be 50. So 50 moles of sodium plus 25 moles of chlorine gas produces 50 moles of sodium chloride. If this number was, if I have 150 moles of sodium, how much chlorine gas would need to react with it? Well, half of it. It's a 2 to 1 ratio, so it would be 75 moles of chlorine, and that would produce, since that's a 2 to 2 ratio of Na to NaCl, so same thing as 1 to 1 if I reduce it, and it would produce 150 moles of NaCl. Remember, all these numbers, these ratios, are going to be in moles. So I can use these ratios, mole ratios, to convert from moles of one substance to moles of something else. I can go from moles of chlorine gas to moles of NaCl, and I can go, if I wanted to, or I could go from moles of sodium to see how many moles of chlorine needs to react with it. So I can use these ratios to solve. And this is a recipe. This is the balanced equation is the simplest form of the recipe, and I can adjust it to get numbers to get greater amounts, and that's what stoichiometry is. If any of you ever go into chemistry, and if you work out in industry, you might be your job might be coming up with reactions and figuring out the stoichiometry for certain amounts and making reactions as efficient as possible to get the greatest yield. Something we'll talk about in a few days. And so looking back at your notes, you should have these guided notes in front of you. and we're going to work a few example problems, and then we get you to do some practice problems on your own. So we need to switch between moles of one substance and moles of another. Use the ratio of the substance, which is found by looking at their coefficients. Now, I'm going to show you two different ways to work these problems, and you can pick and see whichever way that you want to work these out. So I always look and remember this balance equation first goes with all these problems. It's telling me that 1 mole of N2 reacts with 3 moles of H2 to produce 2 moles of NH3, which is nitrogen trihydride, which is ammonia. This is how ammonia will be made at the simplest level. Alright, so, but in this case, the problem says I'm given 3 moles of N2, and it's asking me for how many moles of NH3 would be produced. So this is my given in the problem. This is what is my, I guess, what my unknown is, or my what I want. So it's my unknown. Alright, so to work these problems the first way is I need to come up with a conversion factor. What two things am I relating? Well, I'm relating moles of N2 to moles of NH3. So the way that I relate that, my conversion factor would be for every 1 mole of N2 that equals 2 moles of NH3. Now, I abbreviate moles. Instead of writing mole, I leave off the E. That's just a common way to abbreviate it. That's my conversion factor. So what am I starting with in the problem? I always write my given first. That's going to be 3 moles of N2. And I'm going to make a T-chart, multiply, put that over 1, and then I'm going to multiply by a conversion factor, which is this. Now what's going to go on top, what's going to go on bottom? You know, do I put the 1 mole on top, 1 mole of N2 on top, or the 2 moles of NH3 on top? Whatever I'm looking for, my unknown is what's going to go on top. So I'm going to put that conversion factor on top. So I'm going to put the NH3 on top. So that's 2 moles of NH3 on top. And I'm going to put the 1 mole of N2 on bottom. That way they cancel. My moles of N2 cancel. I don't want those units anyway. I'm trying to find moles of NH3. And this way, if I work it this way, I know what to multiply by and what to divide by. Then it's just a math problem. Multiply what's on top. 3 times 2 is 6. 6 divided by, and then 1 times 1 is 1. 6 divided by 1 is 6. My units left over are moles of NH3. So I always want to write my units down. Alright? Now, there's another way to do this. Let me erase this. I can use my balance equation to set up a proportion and work it that way. So my balanced equation is telling me I have 3 moles of N2. I'm going to put the 3 underneath the N2. And then an X under what I'm looking for. I'm looking for moles of NH3, so I put an X under there. And I'm going to make a proportion, meaning I'm going to put the coefficient over what I'm given. The 1 over 3 equals, and then for NH3, 2 over X. And now solve for X. Cross multiply, that equals 1X equals 6. And then divide both sides by 1. X is equal to 6. My units, I'm looking for moles of NH3. Either way you do these problems will give you the same answer. So I want you to do whatever is easiest for you, whatever you understand. So let's look at our next one. How many moles of H2 are given 0.5 moles of H2, how many moles of NH3 would be produced? Alright, so this time I'm looking at what's my conversion factor. I'm going from moles of H2 to moles of NH3. That tells me that 3 moles of H2 equals 2 moles of NH3 according to my balanced equation. That's where I'm getting those numbers from. So I'm starting with 0.5 moles of H2. Make a t-chart. Put that over 1. I'm going to multiply it by my conversion factor. What goes on top? Whatever I'm looking for. I'm looking for moles of NH3, so I'm going to put the 2 moles of NH3 on top. And put the 3 moles of H2 on bottom. That way my moles of H2 cancel out, then it's just a math problem. And then I would do, 0.5 times 2 is going to equal 1.0. 1 times 3 equals 3. And I'm going to divide. I take 1 divided by 3. That would equal 0.33 repeating. And my units would be moles of NH3. Put a box around my answer. Now, also can work it the other way. So if I'm in 0.5 moles of H2, I put that underneath the coefficient that's in the balanced equation. The coefficient in the balanced equation for H2 is 3. I put the 0.5 under that. That equals, what's the coefficient? I'm looking for moles of NH3. The coefficient for moles of NH3 is 2 in the balanced equation. I put that over x. Cross multiply and solve. 3x equals 1. Divide both sides by 3. 1 divided by 3 equals, and I think that's right, 0.33. I might want to check that. Check that with my calculator. Yes. And that would be my answer. My answer would be moles of NH3. Okay, let's look at the next one. If I'm given 6 moles of NH3, how many moles of N2 were needed? So I'm relating NH3, that's what I'm given in the problem. What I'm wanting to look for is moles of N2. So I'll look back at my balanced equation. What relates those two things? Well, 1 mole of N2 produces 2 moles of NH3. So my conversion factor would be 1 mole of N2 equals 2 moles of NH3. This is what the balanced equation tells me. What I'm starting off with, what I'm given is 6 moles of NH3. And I want to go to moles of N2. So put that over 1. Whatever I'm going to is what goes on top. Moles of N2, so I'm going to put the 1 mole of N2 on top. I want to put the 2 moles of NH3 on bottom. That cancels. I do the math. 6 times 1 is 6. 1 times 2 is 2. 6 divided by 2 is 3. My answer, the units I have left are moles of N2. So if I do this and cancel out my units, I should always get the math right. I should, make sure that I'm multiplying by what number I need multiplying and dividing if I'm canceling out my units. Now, like I said, another way of doing that is setting up a proportion. The balanced equation. If I'm given 6 moles of NH3, how many moles of N2 were needed? Well, if I look at my balanced equation and I go up here and it says I have 6 moles of NH3, put the 6 under there. 8 moles of N2, put the X under there. That becomes 1X equals 2 over 6. Cross multiply. 2X equals 6 times 1 is 6. Divide both sides by 2, and you get the same answer, just 3. Now, looking at this last one, so I'm given 1.5 moles of N2. How many moles of H2 were needed? Alright, so my balanced equation tells me that 1 N2 plus 3 H2 produces 2 moles of NH3. So this time I'm relating moles of N2 to moles of H2. So my balanced equation tells me that 1 mole of N2 is equal to 3 moles of H2. I'm starting off in the problem, I'm given 1.5 moles of N2. Put that over 1, I'm going to multiply by my conversion factor. I'm looking for moles of H2, so I want to put the 3 moles of H2 on top. I'm going to put the 1 mole of N2 on bottom. That way my moles of N2 cancel, and what I'm looking for is the units that are left, moles of H2. Then I do the math. 1.5 times 3 would be 4.5. 1 times 1 on the bottom there equals 1. 4.5 divided by 1 equals 4.5. My units would be moles of H2. So if I have 1.5 moles of N2, it would take 4.5 moles of H2 to react with it. And that makes sense because if it's a That makes sense because if it's a 1 to 3 ratio, if this was 1.5, then that would be 1. If it's 1 to 3, I'll just multiply it by 3 to get, and that would be 4.5. Same ratio. 1 to 3 is the same thing as a 1.5 to a 4.5. Same ratio. Now if I look at the other way to solve this, doing it the proportion way, I put the 1.5 moles of N2 underneath N2, underneath the 1 there. I put X on what I'm looking for. That's under H2, so I put the 3 over X. So I set proportion 1 over 1.5 equals 3 over X. Cross multiply. 1X equals 4.5. Both sides by 1, it equals 4.5 moles of N2. Either way, you get the same answer. Now, so what I'm going to do is work. I want you to skip ahead. What you're going to work on is these practice problems using these equations. I want to look at a couple more problems. Work 1 or 2 with you with a different equation before you get started. So if we look at, let's look at number 11. If we look at number 11, or let's look at number 9. Well, actually, let's look at number 4. Alright, so number 4 says that I am given 0.34 moles of O2. How many moles of KClO3 are used? So I want to know, I'm looking for my unknown is moles of KClO3. My balanced equation tells me, relates these two together by, for every 2 moles KClO3 that react, I get 3 moles of O2. Well, the problem says if I start with 0.34 moles of O2, put that over 1, I'm going to multiply that by my conversion factor to go to moles of KClO3. I want to put the 2 moles of KClO3 on top, because that's what I'm looking for, is moles of KClO3. That's what I want my units to be. And I want to put the 3 moles of O2 on bottom. So I'm using the balance equation. This is a conversion factor that I'm multiplying by. And I do the math. 0.34 times 2 gives you 0.68 over 3. So if I divide 0.68 divided by 3, equals 0.23. And that would be, my units would be moles of KClO3. And that's how you would work these. All these will work the same. Use your balance equation. I will go back and work this the other way. Alright, it tells me I have 0.34 moles of O2. I'll put that underneath the O2. If I'm looking for moles of KClO3, I put the X underneath that and I set up a proportion. That'd be 2 over X equals 3 over 0.34. Then I cross them. Equals 3X equals 0.68. Divide both sides by 3. X is 0.23. Get the same answer no matter which way I do it, so pick the way that you like and stick with that way throughout working all these problems. Now your rest of your assignment is to finish these practice problems.